Hello everyone, welcome to my channel IBwontcrushyou, and today we are going to deal with sequences and series from the chapter Number and Algebra. So let's get started. Problem 1. Consider the sequence 3, 7, 13, 21 and 31 and so on. Write the next two terms in the sequence. So firstly, we have to decide whether the sequence is arithmetic, geometric, or none of them. And we can see that the difference between first two numbers is 4. Between the second and third number is 6. And between the next two numbers it is 8, and between the last numbers in our sequence that we can observe it is 10. So it is none of those sequences, arithmetic or geometric. We can see that our difference every time increases by 2. And if we have to write the next two terms in the sequence, we know that the next number will increase by 12. So our next number will be 31 plus 12, and it equals 43. And our next number after 43, it's 43 plus 14, and it is 57. Problem 2. An arithmetic sequence has first term u1 equals 5 and common difference d equals minus 3. And in A, we have to write down the first 5 terms. So the easiest way is calculating it manually. So u1 is 5, u2 is 2 because we are subtracting 3 from 5. Then we have u3, it is also we are subtracting minus 3, it is minus 1. Then we have u4, it is minus 4, and then we have u5, and it is minus 7. In point B, we have to find the general term un, and in order to find it, we have to use the nth term of an arithmetic sequence formula. It is in your booklet, so don't worry, you don't need to remember this formula. The most important thing is that you need to know that we are using it now when we have to find the general term un. And yeah, we rewrite un, and now we are substituting our given numbers. So u1 is 5, this is from here, plus n, we leave it as a general formula, so n stays in a bracket. Then we have minus 1, and we multiply it by our common difference, so by minus 3. And of course we can simplify it. If you simplified it correctly, you have to have the same answer, so un equals 8 minus 3n. And in C, we have to find the term number for which un equals minus 40. So our un, this is minus 40, so this is our left hand side, and then we rewrite the right hand side, so 5 plus n minus 1 times minus 3, or just this. But now we are typing it into solver and we will have the same result, and our result is n equals 16. Problem number 3. Here we have a geometric sequence that has first term u1 equals 2 and common ratio r equals 1/2. And in A, we have to write down the first 4 terms. So our first term, u1, is already given. It is 2. The second number, so u2, is just 1, because we have to multiply our 2 by half. So it is 1. We are multiplying. Because in geometric sequence we are multiplying or dividing, and in arithmetic sequence we are adding or subtracting. And so u3 is 1 times 1/2. So it is 0.1, and u4 is 0.5 times 1/2, and it is 0.25. In B, we have to find the general term un. So as in previous problem, you don't need to remember this formula. You just need to know that we are using it for the general term in geometric sequence. So un, we rewrite un. Then we have u1. So 2 times r, and r is 1/2, and necessarily we put it into bracket because it is a fraction. So for our sake, it is crucial to put it into bracket. And here we leave n and minus 1, and it is our general term. We don't need to simplify it because it shows us that is a geometric sequence. In C, we have to find the smallest value of n, for which un is smaller than 0.01. So our un is smaller than 0.01, and our un is this. So we can rewrite it, and we need to find n. And we can just put it into our GDC to solver. However, we don't have this sign. So what you can do is write this in solver or graph it with equal sign, and then we will check whether n is smaller or greater than this value. Okay, so I got n equals 8.64. So when we have n 8.64, our left hand side is equal to our right hand side, but it has to be smaller. So we are substituting the closest whole numbers. So n equals 8 or n equals 9, and we have to check for which whole number our equation will be true. So the left hand side has to be smaller than the right hand side. And if you have your answer for this, our left hand side is 0.0156, so that's not true, of course. And for 9, our answer is 1/120, so we can also write it in another form to visualize it. However, it's true, so n equals 9. Problem 4. A bacteria population grows according to a geometric sequence. Initially, there are 800 bacteria and the population increases by 25% every hour. And in A, write down the number of bacteria after 1 hour and after 2 hours. So, we can firstly write that our U1 equals 800. And our sequence is geometric and it increases by 25% every hour. However, we need to remember that when we have increases by 25%, the next number will be 100 plus this 25, of course, percent. So our R will be 1.25 because it is 125%. If you have only 25%, you will see that your bacteria number will be decreasing. So something is not alright. So in order to have a correct answer, you have to include 100%. And we have to write down the number of bacteria after 1 hour. So our initial number is 800, and after 1 hour, because our population increases by 25% every hour, so we have to multiply our 800 by 1.25, and our answer is 1000. So this is after 1 hour, and after 2 hours we just need to multiply our bacteria number after 1 hour by this increase. So it is 1250. In B, we have to find an expression for the population after n hours. So we have to recall our general formula for a geometric sequence, and it is un equals u1 times r to the power of n minus 1. So un equals 800 times r, so 1.25 to the power of n minus 1. In C, we have to find after how many whole hours will the population exceed 5,000. So our population, UN, has to be greater than 5,000. So our UN is this, so we can use this. Is greater than 5,000, and as in previous problem, we can type it into solver with this sign because we don't have this, and check what is n, and then check two closest values and determine the final n. So my n is 9.21, and we have to check n equals 9 and n equals 10, so the closest whole numbers, because for n.21 our equation, our left hand side is the same as right hand side. And if you calculate it for n equals 9, you will have 4768.37, and for n equals 10, you will have 5960.46. So our final answer is n equals 10. Now we have problem 5, and we have arithmetic series given, and in A we have to show that this is an arithmetic series and find the common difference. So in order to determine whether it is an arithmetic series, we have to find a common difference. So what we can do is just subtract from the greater number smaller number, both that are next to each other. So if you know what I mean, it is something like this: 7 minus 4, 10 minus 7, and 13 minus 10. So it is of course 3, it is of course 3, and it is obviously 3. So our common difference is 3, and this is our proof that this is an arithmetic series. In B we have to find the number of terms if the last term is 70. So our last term, so un, because we don't know how many numbers do we have, so un is simply 70. And in order to find n, we can use our general formula for the arithmetic sequence. So un equals u1 plus n minus 1 times d. So our 70 equals 4 plus n minus 1 times our difference, so 3, and we can find that our n equals 23. In C, we have to find the sum of all the terms in this series. And I just wrote in here the general formula for the sum in arithmetic sequence. And these are two formulas, so we will have the same answer. However, here we have d, so common difference. Here we have un, so we use a given formula according to the values that we have. So we have u1, we have n, and we have un, so we can use the second one. It's shorter, so good for us. And so as n equals n, we have 23 because we just found it, and here in the denominator we have 2, and in a bracket we have un, so 4 plus un, and un is the last number, and our last number is 70, and the answer, the final answer is 851. Problem 6. An arithmetic sequence has first term 3 and common difference 5, and in A we have to find the sum of the first 20 terms, and I just wrote the formula for the sum. And we can also write down that we have u1, it is 3, and we have common difference d equals 5, and we have to find the sum of the first 20 terms. So we are looking for S20, and we have to decide which formula we'll be using, and I propose the first one because we don't have un. So we can substitute values that we have. So n is 20 because we have 20 terms over 2. Then we have 2 times u1, so times 3, plus n, so 20, minus 1, and times 5, because d is 5, and from this we have 1010. In B, we have to find the smallest value of n such that the sum exceeds 1000. So our sum has to exceed 1000. And our sum is just n because we are looking for it, so we have to leave it like this, over 2. Then we have 2 times 3 plus n, we'll leave it like this, minus 1, and times the 5, and it has to be greater than 1000. And as in previous problems, we have to type it into our GDC with equal sign, and the value that we will have is 19.9, so we have to check whether it is 19 or 20, and if you will check it, you will see that the final answer will be 20, because for 20, for n equals 20, our sum will exceed 1000. Problem 7. A ball is dropped from a height of 10 meters. Each time it bounces, it reaches 80% of the previous height. A. Find the total vertical distance the ball travels in the first 5 bounces. So in this type of questions, it is important, not necessary, but it is very helpful to draw an image that will show us this situation, because we can easily be mistaken, because you will see why. So we are starting from 10 meters because we have a ball that is dropped from a height of 10 meters, and each time it bounces it reaches 80% of the previous height. So the next height will be 10, because it is our initial value, times 0.8. So it will be 8 meters. Then the next height will be 10 times 0.8 and times 0.8, and it will be 6.4 meters. And I wrote the next heights, and as you can see, we are calculating total vertical distance. So not the path that it bounces, but this 5 bounces. So this and this. Yeah, and we have to also take into consideration that the first vertical height, it travels once, then it has to travel up and down, then up and down. So only the first vertical height will be traveled once, and the next height and these 4 heights will be traveled twice. So we have to include it into our total vertical distance. In point B, we have to write the general expression for the total distance after n bounces. So we basically have to do a very similar thing as in A. However, we need to do it in terms of n. So our total distance will be first distance is traveled only once, so 10 plus, and we have all the other distances traveled twice, so 2, and in bracket we will have something like this: 10 times 0.8 plus 10 times 0.8 to the power of 2 plus 10 times 0.8 to the power of 3, and so on until 10 times 0.8 to the power of n minus 1. And in order to not write 10 every time, we can have it in front of the bracket, so we can write 2 times 10 and then 0.8 plus 0.8 to the power of 2 plus 0.8 to the power of 3 plus dot 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 plus and the last number 0.8 to the power of n minus 1. So this is our expression for the total distance after n bounces. In C, we have to evaluate the total distance after 10 bounces. So we have n equals 10, and now we can use our sum of n terms of a finite geometric sequence formula, and it is like this: u1 1 minus r to the power of n divided by 1 minus r. So we can write it like this. Because our 10 meters distance is only traveled once, we can write it in front of our formula, and we are adding 2 times because the next distances are traveled twice, and we have to start from u1 equals 8 because we just used this in here, so our u1 is 8. In bracket we have 1 minus r, and r is 0.8 to the power of n. We have n 10, and in denominator we have 1 minus r, so 0.8, and we have to calculate it. And our final answer is 81.4 meters. Problem 8. Consider the infinite geometric series 12 plus 4 plus 4 over 3 plus so on. And in A we have to show that the series is geometric and we have to find the common ratio. So in order to prove that the series is geometric, we will find the common ratio, and common ratio is just u2 divided by u1 or u3 divided by u2. In the numerator is the next number, and in the denominator is previous number. So it is 4 divided by 12, and it is 1 over 3, and here we have 4 over 3 and over 4, and we can rewrite it like this, and divided by 4 we can rewrite it as multiplication by the rotated fraction. So it cancels out, and we have 1 over 3. So we have the same ratio, so it is a geometric series. In B, we have to find the sum to infinity. So this is our formula for the sum to infinity. It is also in your booklet, so don't worry about it. You don't need to remember it by heart. Yeah, and now we can substitute the values that we have. So u1 is 12, and here we have 1 minus 1 over 3, so it is 12 over 2 over 3, and when we calculate it, it is 18. Problem 9, we have a sequence defined by un equals 2n plus 1, and we have to write down the first 5 terms. So we have to substitute 1 into n, then 2 into n, then 3 into n, 4 into n, and 5. So these are our answers, first 5 terms. In B, we have to write an expression for the sum of the first n terms. So we have to write equation for sum in terms of n, so n will be the only letter unknown, and we will be using the first formula for the sum because we have d, we have u1, and in here we don't have un, so we'll be using the first one. So sum of n terms, it is n divided or n over 2. In a bracket we have 2 times u1, it is 3, plus n minus 1, and times d, and d is 2, and we can simplify it. And if you simplified it correctly, this will be your answer. And in C, we have to find the sum of the first 100 numbers, so we simply need to substitute 100 into our equation for the sum of the first n terms. So it is 102 plus 100, so it is 100 times 102, and it is 10,200. Problem number 10. A person saves money every week. In the first week she saves $10, and each week she increases the amount saved by 5%. And in A, we have to model the amount saved each week as a sequence. So for sure we know that our sequence is geometric because our amount saved increases by 5%. If we have percent, this means that we have geometric sequence. So this is our formula for general term, and we have substitute everything that we have. So un equals u1. u1 is 10 because this is what she saved in the first week. So it is 10 times r, and we have to remember that when something increases by percent, some amount of percent, we have to also include 100%. So it will be 100% plus 5%, and it is 105%. So our R is 1.05 and to the power of n minus 1, and this is our answer for A. So our final answer is 159.17, and in C we have to calculate after how many weeks will her total savings exceed 1,000. So total savings are the sum, and it has to exceed 1,000. So we can rewrite our formula for the sum with substituted values. So it will be 1.05 to the power of n, because we are looking for it, minus 1, and in denominator 1.05 minus 1, and it has to exceed 1,000. And as in previous problems, we can type it into solver with this sign, and then check whether n is lower or greater than n that we have from our GDC. And I got n equals 36.72, and if we check the closest whole numbers, so 36 and 37, for 36 we have this number, and for 37 we have this number, and our sum has to exceed 1,000, so n equals 37 is our final answer. And that's all for today. Thank you so much for watching. If you have any questions, you can comment down below or via my mail. You can also leave thumbs up if you found this video helpful, and also subscribe to this channel, and see you in the next video.